Okay, hi guys. So in this lecture we'll be continuing on with some more practice examples on pinnacle loan rearrangement and um, the reaction of ketone with Mg in presence of water. Okay, so let's start. So we have first example as suppose we have something like this. Let's be OH here, and then pH here. So in presence of H plus and heat, what will happen is we will get the migration of phenyl here, and two phenols would be attached on this carbon position. Okay, so now it's a little bit interesting problem coming right away. So we have to match the matrix. Okay, so W is free radical intermediate. So this is the second column. Let me write it more clearly. Sorry, X is, let's say X is carbocation, WXY, let's Y be diastereomer will form. So these are all the left column or right column which you have to match with the left column, which I am just going to write in few minutes. Z is racemic mixture will form, and let's suppose T is rearrangement will take place. Okay, and on the left side we have A. When we react CH3, C double bond O CH3 with MgHg, presence of water, we get something like this. Okay, and also let us suppose that this is the second reagent, and third reagent is we pass also on concentrated H2SO4 also into the solution. So what would be the answer or mapping for this case? Obviously in the first step free radical will be formed as intermediate. Carbocation would be formed when we actually do the formed pinacol undergoes pinacolone rearrangement when we pass concentrated H2SO4. So carbocation will be formed. Will diastereomers will be formed? No. So why will diastereomers will not be formed? You can understand if you look at the product which will be formed after the pinacolone has been formed. Okay, there will be no chiral center in the product, that's all I can guarantee. So there will be no either diastereomer or racemic. Obviously rearrangement will take place in the formation of pinacolone. Okay, so these are the metrics on the left column which matches with the right column answers. Okay, we have something like this, and this we react in acidic medium and we heat it. So these are the products formed, this and this. So what happens in this case? It's not a free radical intermediate, carbocation is the intermediate. Okay, carbocation intermediate. Okay, and diastereomers are formed. Diastereomers are stereoisomers which are not enantiomers. These are the stereoisomers which are not enantiomers because they are geometrical isomers, and all the geometrical isomers are diastereomers. Racemic mixture is not formed. For receiving mixtures, two enantiomers for R and S configuration are required, but no such thing is there in geometrical isomerism. Rearrangement does not take place. Okay, let's look at C. We have CS3 here, ET and OCS3 here, and we again pass it on in acidic medium. What will happen is, as you can see, we are passing it in acidic medium with the water as the solvent or polar protic solvent. So what will happen is SN1 reaction will take place. Okay, and after the SN1 reaction takes place, the carbocation would be formed as the intermediate on this carbon. So X would be the answer. And are the diastereomers or racemic mixtures formed in this case? Yes, diastereomers is not formed, racemic mixture is formed, because the again attacking OH group on the formed carbocation would be can either attack from the top side or from the bottom side. Hence, racemic mixture will be formed. No rearrangement takes place in SN1 reaction. Okay, let's take the last example where we have something like this, and in presence of H2 we are getting this compound as something like this and this. So again, there is no strong nucleophile in this reaction, only a polar protic solvent is there. Hence again SN1 reaction will take place and the formation of carbon cation will be there here, and in the RDS it will be stabilized by the resonance or by the conjugating structure, or the resonance by the conjugate double bond which is present near to the alternate to the positive charge here or carbocation here. Hence X and Z would still be the answer. Okay, so let's look at another matrix. This was matrix, the previous one was matrix 1. Now we are going to matrix 2, where we have A compound as something like this. These are coming out of the plane. We react it with H plus and heat it. What will happen? We will get something like this and this. Okay, so what would be the answers for this? Will free radical intermediate will be formed? No. Then is carbocation the intermediate in these two reactions? Yes, carbocation will be the intermediate. Yes, so carbocation will be there. So X. Then are diastereomers formed? Yes, diastereomers are formed. Okay, and I hope rearrangement also does not take place in this reaction. Okay, so let us say B example. Here we have something like this, H, ET, OH, and we again pass it on in presence of PCl5, which is a good nucleophile. Okay, so in this case carbocation will be formed as an intermediate, yes or no? So carbocation would actually be getting formed is a debatable question. I'll just explain you why. So it's debatable because, you know, in this case SN2 reaction will take place because as it is a strong nucleophile, then the Cl minus will be attacking from the back side. Okay, and at the same time OH minus will be leaving this carbon. So slight positive charge would be there in the intermediate. Hence I have written that obviously we have to match this with some of the metrics, as none of the metrics would be matching, because first one was free radical intermediate, no. Then diastereomers will form, no. It will be forming a optically active compound, no racemic mixture will form, and no rearrangement will be taking place. So as to map some of any matrix, we have to map X only, because some carbocationic nature would be there in the intermediate of the SN2. Okay, hence we are matching it with X. Okay, let's see this. We have cis-2-butene and we reacted with Br2 in presence of CCl4. So what will happen in this case? So again we would have what you call as carbocation as the intermediate. Okay, and none of the other things will take place, because it would be a meso compound. Okay, because it will have center of symmetry. Okay, I hope you are able to connect the dots in your mind. Okay, so will it be so for this, if we actually take a look at this, so it won't be having a center of symmetry, because this is a cis here. I didn't pay attention. If had it been a trans, then it would be actually then it would be a meso compound. If it's a cis, then we would be actually having diastereomers. Okay, so rather than having X, I would like to say that it would be having a racemic mixture. Okay, so racemic mixture points to Z. Okay, let's see for this cis 2-butene, and be passing it what cold KMnO4. Okay, so again it would be a meso compound, because again KMnO4 attaches OH from the same side. So in this case it would be a meso compound, and in this case Br will be it is an example of anti addition, and it is an example of syn addition. So in this case we can see that syn addition will produce meso compound. Okay, because it would have plane of symmetry. Okay, and in this case anti compound can have either R or S configuration, because it's a syn, because the cis. Okay, and regarding the above compounds, obviously this is an example of nucleophilic substitution reaction, and this is an example of after that we'll be getting diastereomers, or we'll be getting diastereomers or racemic compound. So I think we won't be getting diastereomers. The Y should not be there. We'll be getting a racemic mixture, because these two are mirror images of each other. I wrote and gave this Y wrongly here. This would be a racemic mixture, so Z would be here. Okay, and what about the type of reaction? The type of reaction is obviously elimination reaction. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing E2 reaction or elimination 2 reaction. Okay, till then, good luck and goodbye.